Breaking news from Starbase, Texas. SpaceX's Starship stands ready for its most ambitious flight yet. Flight 6 represents a pivotal moment in spaceflight history, with teams working around the clock to prepare for a launch that will showcase just how far this revolutionary vehicle has come. The days of concrete tornadoes and ground-digging launches are behind us, replaced by sophisticated engineering featuring a water-cooled steel plate that can handle the immense power of Starship's Raptor engines. The stakes are higher than ever. Pad B's rapid construction promises to double launch capabilities, while 2025's aggressive flight schedule signals SpaceX's confidence in Starship's reliability. As competitors scramble to catch up, from Blue Origin's latest developments to new players entering the reusability game, it's clear that Starship is already reshaping the future of space travel. Welcome to Elon Musk's 24 Hours. Let's dive right in. At Starbase, dawn breaks over a scene that feels more like science fiction becoming reality. The launch mount, bearing the scars of previous launches yet standing prouder than ever, represents humanity's relentless push toward the stars. The morning silence breaks as the water deluge system roars to life, sending a massive torrent skyward in a final test before Flight 6. Engineers watch intently, knowing this innovative system, resembling a powerful industrial fountain, is all that stands between success and potential disaster when 33 Raptor engines ignite with the force of a small nuclear power plant. The real drama unfolds high above the Texas coastal plain. Teams of technicians, suspended at dizzying heights, work with precision that would impress the most skilled surgeons. They're reinforcing the booster quick disconnect housing, a critical component that's faced brutal battles with superheated gases in previous launches. Each weld represents a lesson learned, each modification a step toward perfection. The stakes couldn't be higher. A single weak point could compromise the entire mission. As the sun climbs higher, attention turns to what might be the most ambitious engineering feat in the entire Starship program: the Chopsticks. These massive mechanical arms, originally designed simply to stack the world's largest rocket, are being transformed into something far more sophisticated. Engineers huddle around complex hydraulic systems, making microscopic adjustments that could mean the difference between a successful catch and a catastrophic miss. The precision required is staggering. These massive steel arms must move with the delicacy of a watchmaker's tools while handling forces equivalent to catching a falling office building. The ship's quick disconnect system tells a story of perseverance and breakthrough. After every previous launch, this component emerged battered and broken, requiring extensive repairs that threatened to bottleneck the entire program. But something extraordinary happened after Flight 5. The system survived nearly unscathed. In the world of rocket science, such seemingly small victories can herald revolutionary changes. Engineers speak about it in hushed, excited tones, knowing they may have finally solved one of their most persistent challenges. Meanwhile, a second act in this grand production unfolds as Pad B takes shape. The construction site buzzes with activity as cranes pirouette through the air, removing temporary work platforms with balletic precision. The arrival of the Drawworks motor marks a crucial plot point. This repurposed oil rig technology represents SpaceX's genius for finding elegant solutions in unexpected places. The motor, seemingly modest in size, will control the movement of massive rockets through an intricate dance of cables and pulleys that would make Leonardo da Vinci proud. Below ground, another revolution takes shape. Crews excavate for a flame diverter system that promises to be even more sophisticated than its predecessor. This isn't just another construction project, it's a race against time to build infrastructure that can support the most ambitious launch schedule in human history. The complexity of the system serves as a reminder that even as Starship pushes the boundaries of space travel, it must first conquer the challenges of Earth. Inside Megabay 1, Booster 16 grows like a metallic tree reaching for the sky. The construction process resembles a symphony, with teams working in coordinated precision to join massive steel rings into a structure that will one day pierce the atmosphere. 16 of 24 rings are complete, but this booster holds a secret. It maintains the Block 1 configuration, suggesting SpaceX's strategy of gathering more landing data before implementing major upgrades. This methodical approach, even in the face of immense pressure to innovate, showcases the company's commitment to safety and reliability. Ship 31 stands as both a culmination and a bridge to the future. Its heat shield, deliberately modified with sections removed, represents the final test bed for Block 1 technology. Engineers have installed a new backup ablative heat shield layer, turning this last flight into a crucial experiment that could influence spacecraft design for decades to come. This ship carries the weight of history, a direct descendant of SN8's dramatic high-altitude tests in 2020, while pointing the way toward an even more ambitious future. The launch preparation timeline has been compressed beyond what many thought possible. When Booster 13 emerged from its hangar, teams had just 5 days to prepare for launch, a schedule that would have seemed ludicrous even months ago. The process has evolved into an intricate ballet of machinery and human expertise, each step precisely choreographed. Booster placement, ship stacking, wet dress rehearsal, and the solemn installation of the flight termination system. Looking toward the horizon, Starship's impact on spaceflight becomes clear. The numbers tell an astounding story. While the Falcon 9 can lift 17.5 tons of Starlink satellites to orbit, Block 2 Starship aims to carry 100 tons. With 24 Starship launches planned for 2025 alongside 150 Falcon 9 missions, SpaceX isn't just expanding its capabilities, it's rewriting the rules of space access. This massive increase in payload capacity isn't just about numbers on a spreadsheet. It represents thousands of new opportunities for scientific discovery, satellite deployment, and eventually, human exploration of the solar system. The impact ripples across the global space industry like shock waves from a launch. Blue Origin's New Glenn, standing proud and tall for the first time, represents America's growing commercial space capabilities. The European Space Agency, long resistant to change, has finally embraced the reusability revolution, funding 4 companies to develop their own advanced rockets. Even in China, ambitious companies like Cosmoleap race to catch up, though their current prototype, incongruously placed among city buildings, reveals just how challenging this journey can be. As technicians make their final preparations for Flight 6, there's a palpable sense that we're witnessing more than just another rocket launch. This is the culmination of years of learning, countless iterations, and the unwavering determination of thousands of engineers, technicians, and visionaries. Each modification, each improvement, each lesson learned brings us closer to a future where space travel is as routine as air travel, yet no less magnificent. The water deluge system tests again, its roar echoing across the Texas coast. In that sound, you can hear the voice of progress, of human ingenuity pushing against the boundaries of what's possible. As the sun sets on the launch pad, the massive rocket catches the last rays of light, standing as a testament to how far we've come and a beacon showing the way forward. As the sun sets on the Block 1 era of Starship, we stand at the threshold of a new chapter in space exploration. The numbers tell an extraordinary story. With just 24 launches planned for 2025, Starship is poised to nearly double SpaceX's payload capacity to orbit. This isn't just about bigger rockets or more efficient launches. It's about fundamentally transforming humanity's access to space. While competitors scramble to catch up, SpaceX continues pushing forward. Each launch, each innovation, each lesson learned brings us closer to Elon Musk's vision of making life multiplanetary. From the sophisticated water deluge system to the precisely calibrated Chopsticks, every component of this massive undertaking represents human ingenuity at its finest. Flight 6 isn't just another launch. It's a bridge between what was once thought impossible and what will soon become routine. As we witness this historic transition from Block 1 to Block 2 Starship, we're not just watching a rocket launch. We're watching the future of space travel unfold before our eyes. Stay connected with the latest developments in space exploration by subscribing to Elon Musk 24 Hours. Hit that like button if you're excited about the future of Starship, and share your thoughts about Block 2's potential in the comments below. For exclusive updates and breaking news about SpaceX's journey to revolutionize space travel, click the notification bell. Together, we're witnessing history in the making, one launch at a time. In a major development for space exploration, the next-generation Block 2 Starship has completed its critical full-static fire test, marking the vehicle ready for Flight 7. Internal documents from NASA and the FAA reveal a targeted launch date of January 11 with an unprecedented twist. A specialized NASA aircraft will conduct stealth thermal imaging of Starship's re-entry in complete darkness. This upgraded Starship brings game-changing improvements, increased height, greater propellant capacity, and a completely redesigned forward flap system that dramatically enhances its aerodynamic performance. The stakes are higher than ever. A successful water landing could pave the way for the first-ever orbital velocity launch tower catch attempt on Flight 8. Today, we're covering these groundbreaking Starship developments, Blue Origin's latest New Glenn announcements, and James Webb's universe-altering discoveries. From Elon Musk's 24 hours, let's dive right in. The Block 2 Starship represents SpaceX's most ambitious evolution yet in their quest for full reusability. Standing notably taller than its predecessors, this upgraded vehicle carries significantly more propellant, but the real breakthrough lies in its revolutionary aerodynamic design. Sources close to the project indicate that intensive wind tunnel testing revealed the previous forward flap configuration was creating unexpected turbulence during the critical re-entry phase, a discovery that led to a complete redesign of the system. NASA's involvement in Flight 7 adds an unprecedented layer of complexity to the mission. The agency has commissioned a specially modified high-altitude jet, equipped with cutting-edge thermal imaging systems capable of capturing microsecond temperature variations across Starship's heat shield during re-entry. This classified aircraft will operate in complete radio silence, with both exterior and interior lighting systems disabled, creating what NASA engineers have dubbed Operation Dark Phoenix. The thermal data collected will be crucial for validating computational models that will ultimately determine whether Starship can safely transport astronauts to the Moon under the Artemis program. The recovery operation for Flight 7 showcases SpaceX's growing confidence in their landing capabilities. Internal documents revealed by Interstellar Gateway show detailed plans for a full-scale recovery operation off Australia's northwest coast. The recovery team has conducted multiple dress rehearsals, deploying specialized equipment designed to secure and stabilize a fully intact Starship in open ocean conditions. This marks a significant departure from previous missions, where vehicle recovery was considered a secondary objective. Elon Musk's recent statements about the forward flap redesign highlight just how critical this modification is. The original configuration was not only overweight, but created aerodynamic forces that worked against the vehicle's natural stability during the high-heating supersonic phase. Engineering analysis showed that the flaps were generating up to 30% more drag than necessary, forcing the vehicle to expend additional fuel to maintain its trajectory. The new design incorporates lessons learned from high-speed aerodynamic testing, resulting in a more compact and efficient system. The heat shield improvements for Flight 7 represent another quantum leap forward. Beyond the upgraded external tiles, SpaceX has implemented a revolutionary dual-layer protection system. The new ablative underlayer, developed in partnership with NASA's thermal protection experts, is designed to provide redundancy during the most demanding phases of atmospheric re-entry. Laboratory tests have shown that this system can withstand temperatures exceeding those experienced during lunar return trajectories. Meanwhile, at Cape Canaveral, Blue Origin's New Glenn program is entering its final pre-launch phase. The company's bold claim of a 2024 launch has raised eyebrows across the industry, but behind-the-scenes preparations suggest they're closer than many skeptics believe. The first mission, designated NG-1, will carry the Blue Ring Pathfinder, a sophisticated test platform that will validate key technologies for future orbital operations. The Blue Ring system represents a significant advancement in orbital logistics. Designed as a versatile space tug, it combines high-efficiency electric propulsion with advanced autonomous navigation capabilities. The Pathfinder mission will remain attached to New Glenn's second stage for an extended 6-hour checkout, during which it will demonstrate critical systems, including its revolutionary optical communication array and adaptive power management system. Recent tanking tests of New Glenn have yielded promising results. The vehicle's first stage, designed for a minimum of 25 reuses, has successfully completed multiple cryogenic loading cycles. Industry insiders report that the rocket's innovative propellant conditioning system has exceeded performance expectations, potentially enabling even greater payload capacity than initially specified. While Blue Origin awaits final FAA approval, they've been conducting extensive rehearsals of launch day procedures.